Okay, so today we're going to be multiplying and dividing rational expressions. Sometimes we'll also just be simplifying. So if it's multiplying or dividing, first we're going to factor each part of each fraction. I'm going to say if possible. So sometimes it's not possible. All right, if it's dividing, you need to flip the second fraction. So remember, dividing is the same as multiplying by the reciprocal. All right, then you're going to cancel common factors. And then the last step is rewrite whatever's left over. Okay. Note that if it's monomials, you're going to multiply or divide first. Then you're going to reduce or simplify. Okay, so we'll get to something where we have monomials. Monomials are only one term where there's no pluses or minuses. All right, in the first three problems, there's no multiplying or dividing, so it's just simplify, which we've done before. So you're going to factor the top, factor the bottom. So take out a 3, so you have 3 times the quantity x minus 5. On the bottom, it's a difference of perfect squares, so the square root of 25 is 5, so one time it's plus, one time it's minus. And then you're going to cancel out your common factors. X minus 5 cancels out, so all you're left with is 3 over x plus 5. And it even says identify any x values for which the expression is undefined. So remember, you look at your denominator. X cannot equal 5. X can also not equal negative 5 if you look at both parts of the denominator. So these are your undefined values. In number 2, you're looking for things that multiply to negative 6 that add to positive 1. So we got x plus 3 and x minus 2. On the bottom, you want to multiply to negative 10. So we got positive 5, but it has to add to 3, so it's negative 2. All right, then you look for common factors. X minus 2's cancel, so you're left with x plus 3 over x plus 5. When you look for your undefined values, remember you have to look at both parts of your denominator, even the parts that you canceled out. So x cannot equal negative 5, x cannot equal positive 2. On the third one, we've just got x cubed. If I take out an x, I get x squared minus 8x plus 12. Then it can factor again. So x minus 6, x minus 2 multiplies to positive 12 but adds to negative 8. So now you're looking at x minus 6, nothing cancels with that. X minus 2, nothing cancels with that. But the x cubed over x, we could reduce by taking away an x, right? Or 3 minus 1 gives you 2. And then write down your binomial. So there's your final answer. And then for your undefined values, x cannot equal 0, x cannot equal 6, and x cannot equal 2. Those all come from what would make the denominator equal to 0. All right, so these are the 3 review problems. Now we're going to get into multiplying or dividing. All right, so notice that we can't factor anything in this problem because these are all monomials. So if they're monomials, we're going to do our multiplying first. So 6 times 10 is 60, 5 times 4 is 20. Add my x's, I've got x to the 12th, y to the 5th. Add my x's, I've got x to the 7th, y to the 3rd. Now you're going to reduce or simplify as much as you can. So 60 over 20, that's 3. Subtract my x's, 12 minus 7 is x to the 5th. Subtract my y's, I've got y squared. So my final answer is 3x to the fifth y squared. Now this is a multiplying or dividing problem, so you're going to factor each part. What multiplies to negative 3 that adds to 2 is plus 3 and minus 1. What multiplies to 6 that adds to 5 is 3 and 2. What multiplies here, actually you don't need to do anything here because it's just a binomial and there's no coefficient. Here you have a binomial but it's a perfect square, so it's x plus 1 and x minus 1. Alright, so we're going to look at anything that's the same anywhere on the top with anywhere on the bottom. So if you look at x minus 1, that cancels, x plus 3, that cancels, x plus 2, that cancels. The only thing that's left is an x plus 1. And so you need to have something in the numerator, so you have 1 over x plus 1. Okay? So make sure the x plus 1 stays on the bottom, and then you need a 1 on the top. All right, flip over to the other side, and we'll finish up the last 4 problems. All right, this is a division problem. So we need to flip the second fraction. Excuse me. So we're going to do x squared plus 2x plus 1 over 25x squared. This is still 5x and x plus 1. Now we're going to try to factor as much as we can. 5x doesn't factor. X plus 1, there's no coefficient in front, so that doesn't factor. That's a monomial, so that doesn't factor. But this one does factor. X plus 1 times x plus 1. 1 times 1 is 1. 1 plus 1 is 2. All right, so now I can cancel out one of my x plus 1s, only one of each. So I'm left with 5x times x plus 1 over 25x squared. Final thing is make sure that you can reduce. 1/5 x on the bottom and then x plus 1. So your final answer is just x plus 1 over 5x. All right, in this one we're going to flip our second fraction. Then we're going to try to factor as much as we can. All right, so this is a difference of perfect squares. We got 2x plus 1, 2x minus 1. Here I could take out an x, and I'm left with x squared minus 16. And then that's another difference of perfect squares, x plus 4 and x minus 4. Here I could take out an x, and I'm left with x plus 4. Here I could take out a 2, but not out of here, so it's just going to stay as 2x minus 1. All right, anywhere on the top, look for any common factors. Anywhere on the bottom, top and bottom, those can cancel out, even just the x's. So we're left with 2x plus 1 over x minus 4. Then you're all done. All right, last 2 problems. So it's multiplication. We do not do any flipping, so we're just going to factor. Take out a 6, and you're left with x plus 2. Take out a 3, and you're left with x minus 3. Take out a 5, and you're left with x minus 3. Take out a 4, and you're left with x plus 2. So now if I look anywhere on the top with anywhere on the bottom, x plus 2's cancel, x minus 3's cancel, and I'm left with 6 times 5, that's 30. 3 times 4 is 12. But now that could reduce. So if I divide them both by 6, I get 5 over 2. Then that's your final answer. All right, last one. We need to flip the second fraction. So I'm keeping the first fraction the same, but I'm going to flip this second fraction over. All right, now I'm going to try to factor. So there's no GCF out of 2 and 3, so 2x minus 3 just stays. But here I have a GCF. I could take out a 3, and I'm left with 2x minus 1. Now, for this one, I've got 2x and x. I need to multiply to 2. So something that multiplies to 2 is 1 and 2. And then just double check. 2 times 2 is 4. 1 times x is 1. 4 plus 1 does add up to 5. So you have to check outer and inner. So that's how I factor the top. On the bottom, I also have a 2, so I need a 2x and an x. What multiplies to 6? Just try different things. If I try negative 3 and positive 2, outer is 4x, inner is negative 3x, and if I add those, I get 1x. So that tells me that that's how that adds up correctly. All right, so now I'm going to look at my entire fraction. Anything on the top that's exactly the same as anything on the bottom can cancel. Notice that 2x plus 1 does not cancel with 2x minus 1 because those are slightly different. And then the last thing is there's a 3 right there, so that needs to stay. So here's your final solution. You've got 2x plus 1 over 3 times the quantity 2x minus 1. And you're all done.